Why, hello there. At the end of last episode, I mentioned organisms called macrobacteria. Well, that's what I named them anyway. These organisms evolved from placozoans around 47 million years before the first protozoans, name update pending, appeared. When a clade of placozoans began floating freely in the water, they developed their body more thick and less flat so they will be less easily torn apart. And they also developed a single large eye that detect light, and they also wriggle around a bit to manipulate their movement, though no true musculature. I've called these organisms macrobacteria since they basically live like big bacteria, and I'm going to continue doing that. The ancestral forms live in the benthic zone and fit in the palm of one's hand, though some forms down here grow big enough to barely fit in a large human hand. The most successful forms are plankton that live in the pelagic zone, feeding on autotrophs. Like lunar plantae, filling analogous niches to zooplankton on Earth. However, various forms of these organisms may live in all aquatic ecosystems across the planet, including freshwater and shallow water ecosystems. Reproduction. Ancestrally, they do so whenever it's possible to do so while still having a decent amount of energy left over to live off of for some time. They will reproduce asexually, and pelagic forms, having little defense against predators, will even be more aggressive about this, making young whenever possible, even self-detrimentally sometimes. Counterwise, some forms may produce sperm, which they exchange with others upon collision, which then get used to fertilize an egg. These forms also spread all over Emigin's ecosystems, following the trends of those ecosystems as they do. Other forms may broadcast spawn, similar to the anapods. And do note that the collision spawners are both sexes at once, and both fertilize and get fertilized in all matings, whereas the broadcast spawners have two sexes and are and release gametes that are one or the other. If that phrasing at the end there made sense anyway. Defense. As mentioned before, the pelagic species defend themselves through large numbers, but the many larger forms will utilize a myriad of other mechanisms to protect themselves. Larger forms utilize poison and develop a green aposematic color pattern to signify their danger, but only forms big enough to be clearly seen. Otherwise, predators will just eat them anyway, defeating the point of the toxins. So smaller forms may invest in, well, I would say more personally active means of defense, but well, you know. So just more active means of defense. Okay. Some forms may develop the ability to shoot out a bunch of cells as a threat, and more importantly, as a desperate last resort to propel themselves away from danger. It is a really desperate escape, though, as this can do serious, even lethal harm to the user, even if they can recover due to their simplicity, and this attack may also include toxins that stun, daze, confuse, or otherwise decapacitate the threat. And do note that I use the word threat, since while there are predators purposefully trying to eat them, there's also quite a serious risk of organisms that eat, say, other radial zoans ingesting them by accident, and hardly even noticing, if at all. And so some forms may develop hard armor to defend themselves from active attack, specifically armor that can withstand the radial zoan's digestive tract, which I will get into the implications of near the start of part 3, but anyway, they may form this armor by instead of jettisoning dead cells, using them to form a chitinous structure on their surface, with transparency around the eye. This may also prompt them to develop a dedicated mouth hole, which they can open and close as opposed to just taking in nutrients anywhere on their body, though do note that this is just a hole on their shell and thus does not exist in juveniles. And this hard shell will preclude them from using their existing methods of sexual reproduction. The line that led to these forms had sexual reproduction, but due to this issue, one clade may drop it altogether. And while on said topic, I will also note that it's a common adaptation among sexual macrobacteria to drop it in the name of reproductive speed since they're highly R-selected. This is the section on defense. That was a tangent, pardon me. But another clade of these may develop a new way to do the deed, to get around their shell, i.e. broadcast spawning, and I just realized I already mentioned that being a thing. These do that for a specific reason though. Niches. As mentioned before, there are many forms which fill the niches of plankton, but there are also many generalists and decomposers among their ranks. And there are detritivorous benthic forms which burrow by vibrating their body. These are also the biggest macrobacteria anywhere on the planet to support the sediment above them. This also provides a means of defense. However, this method of burrowing does take quite a while, and their movement isn't exactly precise enough to quickly scramble into a pre-made burrow without something going wrong. So this may lead them to a new method of defense where they vibrate straight downwards to the side to jump over the predator. As you can see, this image depicts that very thing happening to a now very confused early member of a lineage of Frontenachtergum animalibus, which I will dive into in an upcoming episode. On an unrelated note, a branch of Stellopides may adapt their suction cups into small limbs on the bottom of their legs, which they may use to move around the seafloor. And they may evolve a mouth leading to a blind gut separate to their feeding arms and existing excretion system. They'll consume detritus, and with this new food source, they may lose half their feeding arms, leaving them with only 4 arms. So they are now motile, but they are still not very mobile. So I'll call this phylum Il Versa Stella, or the Shifting Stars, as opposed to the original Suctespides, or Suction Feet. And yeah, they have little to nothing to do with macrobacteria besides that they compose some of their prey. They just had to go somewhere, okay? In retrospective, they probably should have been in the last episode, but at the time I thought it was getting too long, but now, well, you know, this is longer. Oops. Oh well. So yeah, this video is finally out 2 weeks later, making it the Emigin Planet Emigin video that took the longest to come out thus far. Yeah, I'm getting back into the swing of things of school. I'm getting, like, most of this video was produced in the second week of its production, so I'm getting more used to doing it under those conditions, so that's good and all. It's midnight, I'm having a very hard time talking here. But yeah, next episode was going to be the last one in the season, but then I decided that I'd make a mini-sode on the episode of about the cells on this planet, because the whole thing had been brought to my attention. It's much more interesting than you'd think, actually, as that came up in school, and that whole thing's just come into my interest now, so I decided to do another episode on the anatomy of all the cells, single-celled organisms and multicellular organisms, so yeah, that's another part. So yeah, anyway, like and subscribe, goodbye.